At the end of this lesson, you are expected to demonstrate understanding of the key concepts of factors of polynomials and solving problems involving factors of polynomials. What's in? Let us recall the terms and the techniques we had in our previous lesson. Factoring is the process of finding the factors of each expression. It is also the reverse of multiplication. What is factor? A factor is an exact divisor of a number. In factoring polynomials, there are patterns that we can follow to make factoring easy and fast. What is a pattern? It constitutes a set of numbers or objects in which all the members are related with each other with a specific rule. Now let us remember these three terms: factoring, factor, and pattern. This time, let us recall the different factoring methods and put these patterns in our hearts and minds to guide us achieve our goal in this video. Here are the different techniques. The greatest common monomial factor, difference of two squares, difference of two cubes, and sum of two cubes, and perfect square trinomial. What is greatest common monomial factor? The greatest common monomial factor is the greatest factor contained in every term of an algebraic expression. For example, 15n cubed plus 12n. The GCMF is, that is right, it is 3. Now factoring out our GCMF from each term of our polynomial, we have 15n cubed divided by 3n is 5n squared. 12n divided by 3n is 4. Therefore, 15n cubed plus 12n is equal to 3n times the quantity of 5n squared plus 4. What is difference of two squares? The difference of two squares are two terms that are squared and separated by a subtraction sign like this. A squared minus b squared is equal to the quantity of a plus b times the quantity of a minus b. For example, 4a squared minus 16. Extracting the square roots, we have 2a and 4 respectively. And then, following this pattern, follow my mouse. Okay, so we have our square root of the first term, which is 2a here, and then the square root of the last term, which is 4 here. So in this pattern, we have addition and subtraction. So we follow that pattern, addition and subtraction. Therefore, 4a squared minus 16 is equal to the quantity of 2a plus 4 times the quantity of 2a minus 4. Now what is the difference of two cubes and the sum of two cubes? They are the results of a multiplication like this. We have here a binomial, a minus b. We distribute the terms in our binomial to the terms in our trinomial. A squared plus ab plus b squared is equal to a cubed minus b cubed. In the same manner, we have a plus b, we distribute our terms of the binomial to the terms in our trinomial. A squared minus ab plus b squared is equal to a cubed plus b cubed. For example, a cubed minus 8. Take note that the pattern here is that we get the cube roots of our first and last term, the cube roots. So we extract a and 2 respectively, following the pattern. That will be the cube root of the first term and the cube root of the second term. Now let's work on to our trinomial. Here we square the first term of our binomial. So look at my mouse. A squared is a squared. Then we multiply the first and the second term. That's 2a. And then we square our last term. 2 squared is 4. Now, for the signs, we follow the pattern so, which is same with the given, opposite to the given, and this one here will always be a positive. Therefore, a cubed minus 8 is equal to the quantity of a minus 2 times the quantity of a squared plus 2a plus 4. Lastly, what is a perfect square trinomial? It is the result of squaring a binomial. It has the first and the last terms are perfect squares, and the middle term is twice the product of the square roots of the first and last terms. Let's try one example. Now here, our example is 4a squared minus 16a plus 16. So we are going to follow this pattern because it is a subtraction, and here it is also a subtraction. So therefore, our answer would also be a subtraction. Then we extract the square roots, which are 2a and 4 respectively. And then we multiply. 4 times 2a is 8a. 8a times 2 is 16a. Very good. We have a perfect square trinomial. Now this time, following the pattern, we get our square root of the first term and then the square root of our second term, and then we express them as a subtraction according to the pattern.